Okay, I'm just going to briefly talk about Sage, and I realize some people are looking at what they wonder. I wonder if Sage can do these problems over here. Let me just type it in sum, and since Sage has a default x as a variable, I'm just going to use x. So sum x squared. I get experimenting, and what do you get? E raised to the power. That would be x cubed then, right? Again, I'm using x instead of the letter n, and then I can say n. And where does n start? At 1, and it goes off to infinity. And OO in Sage looks like an infinity. Let's see what happens. All right. Can't do it. All right. Just need a summation variable. Oh, you know what? Maybe I didn't type that in. Yep. I see it now. I put n down. I meant x. And then it's going to be 1 to infinity. Sorry about that. What are you over there? It just returns, it can't do it. It just returns the same thing to me. So I'm just going to go through these problems over here. And you might say, oh, it's just remarkable. It can't do it. You know, I could probably change the infinity to maybe 10. I want to see what happens over here. And I guess something looks pretty crazy, right? So maybe I want to do a numerical approximation to that. So let me do this over here and dot n. Let me see if it can handle that. And I get a numerical approximation to that. And again, you may say to yourself, well, what if I tried 100 instead? And you get an idea I can do a sum, but it's a finite sum. It's not an infinite sum. All right. All right, let me go to the next question. I think you get the idea. I'm just adding things together. You notice that between 10 and 100, there's not much of a change between the problem. All right. Let me just see if I can do 5. How bad that is. I'm starting to be curious about it. Maybe I typed something in wrong over here. Maybe not. All right, let me go to the next one. Let's see this one over here. Let's see what happens. So I'm going to clear the screen and just having fun with Sage, if there's such a thing. And I'm going to type that in -1 raised to the power. Again, I'm using x because it's built into Sage. Now, remember in Sage, there is no like ln thing. It's log. Log is base A. And that's true in all upper level math courses. And then divide by the square root of x. And then I'm going to say x from 1 to infinity. And again, I'm just displaying that you're going to find out it can't do it either. Right? Let's put this down over here. And let's put down 10 instead. And then I'll approximate it. And you get that number over there. You get the idea. I can approximate these. Let's try this one. All right. Sum. Let's see. That would be 2 to the 1 over n. That's the nth root of 2 minus 1. I can't use n. I have to use x. Let's see. -1. And x is my the counter, and it's starting at 1 and going off to infinity. Sum is divergent. All right. That's good to know, by the way. And what I mean by that, it says it diverges. Right? We knew it diverges. Now, do you remember the other ones we did? Like we were saying, this one over here converges. Now, Sage didn't come back saying it was divergent. Sage came back and say, well, I can't do the sum. It didn't say it was divergent, though. All right. So you could keep going through this, and I would recommend you give it a try. And, you know, certainly look at this one over here. Let me just clear it because there's a lot of stuff on the screen over there. Sum. Let's see, that's -2, right? To a power. And what's the power? It's twice n. So 2 times x. I can't use n, right? And then we're going to divide by x to the x. All right. And then we're going to say x is starting at 1 and going off to infinity. All right. Before I go forward over here, we did that problem over here. Let me see what I said. It converges, right? Let's see what happens. It doesn't do it, but it doesn't say it diverges, though. And that's nice to know. All right. You keep going through this. This one over here. Let's see. Let's write it down. So sum sine x. X starts at 1 and goes off to infinity. Now, this is a divergent series. We've already shown that. And what does it say? Sum is divergent. You clearly see at the bottom. Let me clear again. Again, you're free to do this on your own. I don't think I want to do this one over here. I'm kind of looking around. Let me see if I can try this one over here. Sum x squared, whoops, I'm sorry about that. I got to try that again. X squared plus 1. You're going to learn a lot by typing, by the way. You're going to, some of the things you're going to learn is you may not think, you think you can type and you really can't type. X is starting at 1 and going off to infinity. All right, sum is divergent. What do we know about that sum? Also divergent. We knew that. All right, we did that. Again, I'm not going to type this one in, but I guess you could if you wanted to. This one over here, I don't think I want to type it in. This one, I don't think I want to type that one in either. This one, I don't think I want to type that one in either. But you get the idea. You could do this over here and do okay with it. All right, let me just see if there's anything interesting to type in. Okay, this one will be done for you later. And I want to point out it's important, so I'll type it in now for you. Sum, it's going to be -1 to the x power. And I will do this later too. 2 star x plus 1. And we're starting now x from 0 to infinity. Let's see what happens. Wow, that one did it, quarter pi. All right, that's remarkable. By the way, it's not remarkable, but anyway, you might find that to be remarkable. All right, so that's about it for the little sage introduction on that section. Okay, so I guess we'll have to come back to it another time. And what section were we in? We were in section. Let me make sure I'm doing the right section over here for you. We were section 20. Thank you so much.